Hello and welcome to Future-Proofing Your Cisco Collaboration. We'll be walking you through navigating these EKU sunsets. The plan here is to ensure that service is secure and services remain uninterrupted. A little bit about me, my name is VictorRolandson. I have been in Cisco for about 10 years. I first worked in on-premise team, and then I moved to the telepresence team. So now I troubleshoot traffic all the way from the internet to the gateway. I'm here with my colleague, Randy Valverde.
Hello, everybody. Thank you, Victor. My name is Randy Valverde. I've been in Costa Rica. I started there in 2013, moved to Mexico in 2017, where I joined the telepresence backbone team. Today, we're going to be talking about a big change that's coming. We're going to start with our introduction, of course, but we'll go over Secure UC Collab, what is it today, what MTLS is, how does it work. We'll look at what's changing and why. This is the main purpose of the presentation. We'll look at the proactive and interim measures you can take before you implement these solutions. We'll look at the solutions that we have adapted to our collaboration products. We'll go some troubleshooting, and lastly, we'll look at Beyond the Sunset. What are we to expect after the change takes place? So to start us off, Victor, please, can you walk us through what Secure UC Collab is?
Thanks, Randy. In our hyper-connected world, collaboration is the heartbeat of every enterprise. It connects people, devices, environments even. And no matter what your deployment is, it could be small, medium, large, or complex, Cisco meets exactly where it is. You could be having on-prem only, or it could be a little bit of both. Maybe some cloud, maybe having APNS, leveraging APNS and having MRA, or doing full Cisco cloud. Whatever it is, as an admin, you should make sure that your security profile is uniform across the board. Make sure that everything is secure and services remain interrupted. That's the task. Now, how do we do this? Before I get to my next slide, I want to explain something a little bit about me. So I like to volunteer. And when I volunteer, I do something that's different from what people do, and I'll explain why. This all started a few years ago when I first started volunteering. So I went there, I checked my name on the list, and then the lady gave me a name tag and said your name. She asked me to put my name there. And I don't know why I do this, but I asked again my name here. She looks at me and says, yeah, whatever. And so at that moment, a light bulb clicked in my head. Do you remember the 90s movie Home Alone, where Macaulay Culkin says, I made my family disappear? That smile? That moment, my head just clicked in my head. I was like, the possibilities were endless. I could be Chuck Norris, Bond, James Bond. I mean, it's not every day you tell Megatron to pick his sack of potatoes and put it over there, right? Try saying it with a straight face. Yeah, but in that environment, that works because you're helping people out and you want everyone to be in a good mood and working together. In collaboration, that doesn't work so well. You need to verify with whom you're having a conversation. You need to verify the person or the colleague you're talking to is who they are. So how do we do this? We need digital identity. Now, I just told you a few moments my name was Victor, and now I told you I changed my name. So how can you verify that this badge, my name on it, is actually who you say it is? Anyone? Sorry? The QR code, yeah. But who issued this badge? Cisco, right? The third party. So you trust, sorry? Exactly. You trust Cisco as the third party. They verified my identity, and as well, I trust Cisco to verify yours. So we can have a secured or null conversation. So when moving from your internal network to somewhere external, you need to have a way to identify yourself, to verify the source of the network or the communication. You need to have like digital identity. Each party needs to. Or digital passports, you probably heard some of my colleagues say. Certificates are used as a digital identity. And they're the foundation of many of the encryption standards we use today. SRTP, TLS, or even MTLS. Now, talk a little bit about MTLS. I'm going to hand off my colleague, Randy.
Thank you, Victor. So MTLS, going off what Victor just said. What is it? Let's start with what does it stand for? MTLS stands for mutual, this being the important part for this session, transport layer security. Different to standard TLS, where only the server is required to authenticate against the client, MTLS mandates that both the client and the server authenticate to each other. They do so using digital certificates. In a given connection, the devices are given a client and a server role. This depends on who starts that connection. So the device that starts the connection is considered the client. The device that receives that connection is considered the server role. This concept, it's important to be understood, so I'll give you a small example of what it is. When you visit a web page, you open a browser, you visit whatever web page you have, the server that you're connecting to will share its certificate with your computer. It's your computer that is in charge of verifying that certificate, giving you a green padlock or a gray one, depending on the browser that you're using. But it's an indication that you trust that website and that you're connected to the place that you want it to go. If we look at our collaboration deployments and see the expressway C and the call manager, for example, when they talk to each other in an MTLS connection, we expect both the expressway C and the call manager to share their certificate to each other, and they're both expected to verify that certificate is trusted. That's MTLS. That's the difference between MTLS and TLS. Now, our collaboration devices have different use cases. For example, call manager, you can use CBOAuth, you can have WebSockets, you can use outbound LDAP connections. Those use cases depend on the Tomcat service. And therefore, whenever they require to use a certificate, they will use the Tomcat certificate. But within the same call manager, you also have SIP trunks, you have phone connections, you have CTI. Those depend on the call manager service. And so when those use cases require to use a certificate, they will look to use the call manager certificate instead. This is true for different products in Collab. So we can also look at the IMMP. The IMMP also has the SIP proxy and the SIP trunk, which rely on the COP certificate. Right. We also have the XCP router, which relies on the COP XMPP certificate. And so depending on the use case, they might use different certificates. Now, it's not true for every product. The expressways, for example, you only install one set of certificates on it, and it will use that certificate for everything, whether it's B2B communications, WebEx Edge audio, MRA connectivity, traversal zones, it will use the same certificate. Now, how does this all tie into certificates themselves? Well, these certificates have an attribute called extended key usage, or EKU for short. The extended key usage determines in which capacity can that certificate be used by the device in which it is installed. There are usually two options that we're going to look at for the purposes of this presentation. There are more options, but we'll focus on these two for the purposes of this. So we have server authentication first. This is the default one and the one that you will see in most, if not all, of these certificates that you look at. And this is just the standard. Even when you set up a private certificate authority, you will see that the template to sign certificates has server authentication by default. Mm-hmm. Client authentication, on the other hand, it's what is required for MTLS to work. When you look at these certificates, this is how it looks to have both of them in the certificate. Now, there are changes coming. This is the purpose of the presentation. So, Victor, can you walk us through those changes?
Right, sure, I can. So now we know about certificates, EKUs. No, I didn't have any doubts. You knew that a refresher is always welcome, right? So we know about that. We also know what CAs are, the certificate authorities that sign and issue certificates. These CAs follow guidelines set by the root store. The root store, Microsoft has them, Safari has them, Google has them. And that's what I'm talking about, Google. A few years ago, Google made a change in their root store. The requirement for CAs to sign certificates differently. Now, if you don't know what root store is, it's kind of like a bouncer in a club in Vegas. So they tell everyone, they set standards on what you should do to be included into their club. And so CAs have to follow suit. 7% of all browsers in the world are Chromium-based. Edge, Opera, Brave, all Chromium-based. And all the other browsers feel that this is the right move, using the least privilege model. What that basically means is you're giving access, the least required amount of access to do a specific task. As Randy mentioned, if you're going to a web browser, going to Amazon.com, you need to verify it is Amazon, right? Why does Amazon need to verify it's you? It doesn't need that EK client view. Smart, right? I agree with it. It's pretty smart. So they set the standard on what CAs should sign. removing the dual purpose certificates, great, smart, but hang on. We need dual purpose certificates for MTLS. So how does that affect us? From our testing, we noticed that call restricted failures on call manager and the gateway queue. We also noticed WebBridge 3 failed when MTLS wasn't working. The key services on IAM presence were affected as well. The services that update your presence and send IAM messages, those failed as well. Unity isn't left alone. Key features in Unity like unified messaging and visual voicemail were also affected as well. So like 80% of your collaboration down because MTLS isn't working. What can you do about it? We have two options. We can be reactive, wait for it to happen, or be proactive. Personally, I think proactive is the way to go. So a few things. When you review the slide later, you will need to make a few decisions. First of all, you need to know your devices you use. You probably know that. If I ask you, you probably know what devices you use in your network. Another thing is you need to determine the traffic flow. What service are they connecting to? They connect to the call manager, they connect to the gateway, VCS, or going straight to the cloud. Easy, right? Next, the next thing we do is to open the servers up. Look to the web page and look at what certificates those servers are using. What I need you to look at is the CA that signed them, or CA that signed them and the expiration date. Now, if you know the CA already, that's great. Pull up the web page and then look at the certificates that CA signed and expiration dates of those certificates, those active certificates. Now, by the time you've done all this, you've done more than 50% of the work, because this is information you need for the next step. The next step is actually decision-making time. So for this, take a deep breath and time to think about what to do. Next we're going to talk about interim measures or workarounds, and I'm going to come back with the solutions. And how about to my colleague Randy?
Thank you, Victor. So before we go into the solutions, because you'll see the solutions are mostly focused in upgrading your devices. So upgrades take planning, they take time, especially if you have big deployments, they take a lot of time and a lot of planning. So what can you do in the meantime? We have a couple options. One, renew early. Right. Why do we want to renew early? Well, the idea is we want to extend the amount of time we have before we need to upgrade the devices. So renewing early helps because different CAs will have different dates in which they will implement their changes. Some CAs have already removed the client authentication at all. Some will remove it up until the deadline of when they can have it. And some CAs still offer it or will continue to offer it even after, but you will have to request it. So check in with your specific CA of choice. It's important to see where they're at. Now, why do we want to plan and check? Well, the certificates, even beyond the deadline, are still valid up until their validity period. So if you manage to upgrade or to renew your certificate before the change takes place, then you're going to have a longer period of time before you need to upgrade. What is the other option we have? Well, changing CAs. Of course, some CAs will still offer the service. In this, you will want to check on which CA do you have, what do they currently offer, will they continue to offer it later? And accordingly, if you need to switch, you do need to consider that both your clients and your servers in each interaction trust that new certificate authority just to avoid outages that you might have during the process. Now, we discussed what to do in between before you need to fix it or before you need to upgrade. But Victor, what are the solutions that we can implement in our collaboration products?
Thanks, Randy. So across our collaboration portfolio, we've made certain changes. User enhancements and security enhancements as well. Let's start with Expressway. So Expressway 15.5, it's downloadable from the Cisco web store. We've added two client certificate stores, the client certificate and the client certificate store and the server certificate store. Those certificate stores are independent of each other, meaning they have their own private key. So if you create a certificate in the server store, it's going to be different from client store. Now, what happens if you upgrade from lower version to 15.5? The certificate you have will be copied over to both stores, ensuring backward compatibility for any MTLS connections. And that also applies to Acme as well. Now, what if you're already on 15.5 and you want to update your certificate? Great, you can do that. Once you upload your certificates to the server store, there's an option to copy the certificates to the client store as well. Less work to do. So you just click the box and upload the certificates, and it gets copied to both. This helps with integration with third parties and WebEx audio. Now, talking about, we also have the option to disable the client EKU check. It's the SIP-TLS certificate extended key usage check-in mode. If you run that command without any parameter, it's going to show you the current status, which is on by default. Now, if you run it with a parameter, :off, it turns it off. If you want to turn it off, of course. But when you run command again without any parameter, it shows you the current status as it off. Now, I'm going to break away from protocol. So the next thing I'm going to show you is not protocol. We do not usually talk about new releases or upcoming releases, but I want you guys to make an informed decision and to plan ahead. So we're making an exception this time. We're going to talk about the next release of 15SU5, Call Manager. Now, 15SU5 addressed this also. Now, as Randy mentioned, these are services that actually are MTLS dependent. And for those services, we've created a server and client stores as well. They're also independent, and they also have their own private key. So if you create a certificate on Tomcat server, it's going to be different from certificate upgrade on the Tomcat client's certificate store. There's also the option to disable EKU checks on Call Manager as well. Now, I can't talk about release date. I know it's going to be on this half of the year. So if you have questions about that, you can meet me after the session, and we can talk about it and point you in the right direction. In Cube, they also did an enhancement. They changed a few things. In IOXC 26.1.1, they added a command, the client trust point, where you can actually attach the client certificates to the same interface as the server certificate as well. So having both dual certificates on one interface. Pretty cool, right? I think it's pretty cool. But yeah, so they did that, and you can actually, this helps with backward compatibility for services that require MTLS. Now, one thing to note here, and I've said it often over and over again, the client certificates, when you're trying to sign it, please check your CA. Make sure that the CA can sign a client certificate with the client EKU. And if you can't use it, or you can't sign it, make sure to try using a private CA. But the caveat here is to make sure that the entity or whoever you're going to collab with, the company you're going to collab with, also trusts that CA. Otherwise, it's going to fail. Now I'm going to hand off to my colleague Randy to guide you through some troubleshooting steps.
Okay. Thank you, Victor. So troubleshooting. Let's go first what a TAC engineer goes through in the day-to-day with these issues. So first we need to understand a standard TLS or MTLS exchange, because we need to know what to expect before we troubleshoot it. So as mentioned before, we have a server and client role. After the standard TCP three-way handshake happens, we'll see a client hello from the client to the server. This sets the tone that this is an encrypted connection, or this is intended to be a TLS connection. The server should already know by the port that was used. Nonetheless, this sets the tone, hey, I want to talk encryption. The client hello serves other purposes. It also brings which ciphers does the client support and which TLS version. We expect the server to respond with several messages. So we will see the server hello, where he is speaking from the client hello, which TLS, which ciphers we're going to speak. So the client offers and the server chooses. We'll see the server certificate, and we'll see a server key exchange. Now, up until this point, this is standard TLS, not MTLS. But this is where MTLS comes in. So for MTLS, we will see a client certificate request going from the server to the client. What this tells the client is, hey, you need to also provide a certificate because I need to authenticate you as well. We do expect the client to then provide a certificate. There is a client key exchange following that. They're both, as mentioned before, in charge of verifying that that certificate is valid and trusted. Then they exchange a change cipher respec. And finally, we will see encrypted data. This is a standard TLS or MTLS exchange. And this is what we would expect to see. Why do we need to know this? Well, when we get cases, we don't know if the problem is the EKU missing, or if the problem is a TLS version mismatch, or maybe a cipher mismatch. So it is important to know what to expect before we apply it to whatever you're troubleshooting. Now, if we look at as an example, the Expressway E and the Expressway C have multiple communication channels between them. You have the SSH tunnels, you have the traversal zone, among others. Looking at those two specifically, they're both MTLS exchanges. And so for each one, we will expect to see three-way handshake and the MTLS exchange that we just reviewed before. In those scenarios, we expect the Expressway C to send its certificate to the Expressway E. In the Expressway E, it's expected to verify that that certificate has client authentication. Why? Because he's receiving it from a client, right? If the Expressway E sees that certificate has server only, then that connection is expected to fail. The same goes the other way around. When the Expressway C receives that connection from the Expressway E, he needs to verify that certificate as well. So beyond the sunset, what are we to expect after the deadline that Chrome has set out, and the changes that are coming? We're only going to ask two things from you. The first one, review and evaluate your deployments, and then engage stack. Now, that might seem simple, but what do I mean by that? So, review and evaluate means, as Victor mentioned before, go through your deployment to your devices, see what uses the client authentication and is needed, see if their certificates are close to expiring or not, and take the decision whether you want to renew them early, if you want to use another CA, etc. But most importantly, if you still have doubts, if you're not sure of the changes that you want to do or you're going to do, please reach out to us. We'll be glad to help you out, go through your deployment, through your doubts, and just clarify whether this will affect you or not. With that, we have covered what's the change, how to address it, what can you do in the meantime. So, Victor, please take it over.
A few housekeeping things. Please complete the survey. You could win prizes. Who doesn't want a free Cisco Live ticket for next year? You don't want one? You want one? Exactly. So complete the survey, and then you'll win prizes. Also, if you haven't scheduled Meet Your Engineer, please do so. They have labs over there, the Dev Node Zone, and the Capture the Flag. They're fun. If you haven't done it, please engage and do that. Do we have time for questions? Okay. I want to say thank you so much. Sorry, questions. Who has a question? Does anyone have a question?
The 15.5 update that you mentioned for call managers, that can be made across all the other platforms, Unity, CER, etc.
Okay. Your question is if the 15.5 will be also available for other platforms, the changes. Yes. But I can't talk about that right now. Shh. Sorry. UCCX? Let's talk about after the session. I can't answer that question yet. But let's talk about after the session. Okay. Any other questions?
Yeah, thank you, guys. I was wondering about the certificates that you were saying about the 15.5 version of Call Manager, for example. If we're going to do integrations with another third parties, like for SSO or things like that, we will need to exchange the certificates from the publisher and the subscriber this time, or, well, because now I understand they are going to be for the specifically for each of the nodes of the deployment, or how it will work with the...
Yeah, so the question is, if you're having separate certificates now, do you need to exchange both with the other devices that you're exchanging? To clarify on that question, what the products are separating or segregating is you have a server certificate and you have a client certificate, but you can still use the same for the different call managers that you have within the same cluster. But what's going to be separate is you're going to have a server certificate that it's server only, and you're going to have a client certificate that it's client only. But yes, to your question, yes, if you're going to send that client certificate to another product and they need to trust it, then you need to exchange the certificate authority with them as well. Any other question?
Well, if no questions, thank you so much for spending time with us. Thank you for your time. Thank you so much. I really, really appreciate it. Thank you. Have a wonderful rest of your day.